Hi, my name is Darian Hirotsu, and welcome to our NEC Software-Defined Networking Technical Deep Dive series. In this video, we'll illustrate NEC's multiple data center solution called UNC, or Unified Network Coordinator. As data center operators, we're challenged with networks that are growing in size and complexity due to network management being handled on a per-device basis. This video is for technologists looking to simplify data center operations and to better utilize their existing network resources. In this session, we'll highlight NEC's solution for multiple data center deployments. First, we'll talk about some industry trends impacting networking, namely those increasing network complexity and causing operational inefficiencies. Next, we'll do an introduction to NEC's solution for this problem called UNC, or the Unified Network Coordinator. Next, we'll talk about benefits of the UNC. We'll illustrate how UNC can increase scale and simplify data center network operations. And lastly, we'll highlight a demo so you can see the UNC in action and how it can visualize both the physical and virtual networks. So networking technology is undergoing a fundamental transformation. For example, with big data, we're seeing exponential growth in server-to-server traffic, and the network has to keep up with that growing demand. With server virtualization, hosts are no longer stationary, meaning they're moving throughout the network, which is causing problems with enforcing consistent security policy. Also, with new access models such as bring your own device, we're seeing more and more networked hosts. All of this is causing operational complexity and creating more work for us as network engineers. In order to address these issues, networks have to change and must achieve the following. First, higher business agility, meaning networks have to be able to support more and more applications at the speed that business demands. Also, regarding business continuity, networks have to have higher uptime in order to support critical applications. At NEC, we envision a dramatic shift in conventional networking. We see intelligence being removed from hardware and a centralization of the control plane, allowing programmatic and dynamic changes in network infrastructure. This is at its heart what SDN is all about. As such, NEC's SDN ProgrammableFlow networking solution helps reduce the complexity and manual process associated with traditional networking, which is managed on a device-by-device basis. The component to centralizing operations and management in NEC's ProgrammableFlow SDN product family is the UNC, or the Unified Network Coordinator. So recall that traditional networks require substantial planning and manual configuration at a per-device level, since each networking device is managed on a device-by-device basis. When you're talking about multiple networks across different physical locations, this issue is compounded. The UNC allows operators to configure and deploy virtual networks regardless of physical location within a single console. This enables a number of things. So first, consistent security policy. So when there's only a single pane of glass to deploy a new change, we no longer have to go device by device to make a new change. Secondly, it enables better visibility into traffic patterns. So rather than having to run a command on every device in the network to see traffic patterns, we can get all that information from the UNC console. Thirdly, we have better traffic control. So having the UNC as a central point to configure the network, we no longer have to make changes and traffic engineer using complex protocols and obscure CLI commands. Also, with the UNC console, network topologies are automatically discovered and displayed in a single place, and we're talking about both the physical and virtual networks. Here is our first view into how UNC manages multiple data center networks. At the top of this diagram is the Unified Network Coordinator, which can run on any typical server. We have multiple programmable flow controllers and programmable flow switches at separate data center networks, which could be geographically dispersed. At the center of this diagram, we have a boundary labeled B1, which represents any data center interconnect provided by dark fiber or traditional network appliances. Although there's a single UNC icon, the UNC is not a single point of failure, since it does not participate in the control plane. All control plane and open flow functions stay on the programmable flow controllers. The UNC provides us the central point to operate and deploy configuration to multiple devices throughout the network. The UNC enables consistent business policy. With the UNC, we centralize operations and management of the physical and virtual networks. We also get access to advanced automation of network policy, since we no longer have to deploy configuration on a per-device basis. This in turn enables improved QoS. We also get flexibility in management across networks and locations, since UNC can manage PFCs regardless of physical location. UNC enables reduced deployment time for new network applications and services, since again, we're no longer configuring or deploying CLI commands to every network device manually. The UNC enables increased visibility into traffic and network assets, since we get a single console to see flows throughout the network regardless of geographic location. The UNC enables 10 times the scalability previously delivered by a single PFC, as we'll see more in the next slide. In this diagram, to the left, we see prior to UNC, a single programmable flow controller could manage 200 programmable flow switches, 80 physical racks of servers or virtual machines, 1,000 virtual tenant networks, or 10,000 VLANs, and 1 million flows. Now with the introduction of the UNC, we can manage 10 separate deployments of programmable flow controllers. This gives us 10 times the scalability previously seen in SDN. With that, let's go ahead and move on to the demo so we can see the Unified Network Coordinator in action. In this demo, we'll highlight how the UNC may be used to visualize both the physical and virtual networks while enabling better utilization of scarce data center resources such as WAN bandwidth. From this view, we're highlighting the web GUI from the Unified Network Coordinator and the physical topology that it manages. We have two networks, Data Center A and Data Center B, each consisting of programmable flow controllers and programmable flow switches. At the center of the diagram, we have a bypass controller, which represents devices external to programmable flow. In this scenario, those are two traditional network devices providing data center interconnect. Next, we'll highlight the virtual tenant network deployed by the UNC over the physical topology. Shown here is the VTN that spans Data Center A and Data Center B. At the center of the VTN, we have two logical devices, WAN 1 and WAN 2. These represent our traditional network devices providing data center interconnect. Next in our demo, as shown in the upper left, we'll start a ping test that spans Data Center A over to Data Center B. As shown here, we can use the UNC to display the flow that spans this virtual network. Notice that our ping traverses the links over the WAN 1 device. Next, we'll use a traffic generator to simulate a critical file transfer. On the UNC, we've pre-configured flow filters to redirect the file transfer over the unused WAN 2 device and its associated links. Notice here when we highlight the flow, this is our traffic from our traffic generator. We've redirected this flow over the unused WAN 2 device. As shown in this view, we can better utilize data center bandwidth over the WAN, since we can use flow filters to redirect specific sets of flows over different unused links. This concludes our demo of the UNC, where we highlighted how the UNC may be leveraged to visualize both the physical and virtual networks, and how it enables better utilization of data center resources. To recap this session on NEC's solution for multiple data center deployments, we discussed the following 4 bullets. First, we talked about industry trends impacting networking, namely those that cause operational inefficiencies and increase data center network complexity. We introduced the Unified Network Coordinator, which is NEC's solution for these problems. We discussed the benefits of the UNC, including increased scale as well as simplified operations. And finally, we illustrated a demo of the UNC in action and showing how it can visualize both the physical and virtual networks. In this video, we illustrated NEC's solution for multi-data center deployments called UNC, or the Unified Network Coordinator. For more information, consult NEC's website to get documentation on the UNC for more complex configuration scenarios. We look forward to seeing you in the next video.